right, stop. Hi, so if you noticed in that recording or the demo that I gave with the robot, you'll notice that it actually doesn't come to complete and smooth stop. That is because the back right wheel is coming loose and eventually broke off. But you get the idea of the 2-button command, so just forward and back. So I wanted to show how I did that today. And it's all using something called ROS SDK, which is Software Development Kit. And what I'm going to show you guys is how to get ROS up and running, and what steps I took to do that. So there's a lot of steps in order for ROS to actually work. It's not just a one or two, it's multiple. So for the first thing we're going to want to do, I didn't want to take a video of the screen because obviously that wouldn't look super great. But first we want to run ROS core. So ROS core and downloading tutorials are very readily available. If you've noticed right here, I have the Noetic ROS distribution. And what you're going to want to do first is run ROS core. And once we run ROS core, we're going to open up a new tab, and we're going to run this command right here. So what we're going to run is ROS run ROS serial Python serial node.py, and then this is the port that we're using for Arduino. But one thing that you do have to remember is, since it is a software development kit, you can make and it's open software, you can make your own files, and that means that your files aren't going to be located in exactly the same spots. And the other thing you need to remember is you need to source each time you go into the folder. So we're going to do source devel/setup.bash. And now that that's sourced, we can run this command, and it should know exactly what we're doing. There we go. So it connected with the Arduino. Obviously, you can't see the Arduino right now, but it shows that it's connected. If it didn't, it would give us a lot of different errors right here. So that's a really good sign. If you don't see a ton of red errors, it usually means that it's connected successfully. So now that we run the ROS core and the Arduino file, which I think I should have GitHub. GitHub should have the ROS serial Python. If you look it up with the ROS file, it's also free and open source. So feel free to check that out if you'd like. The other part of it is running the Arduino code. So I already ran the Arduino code. You can't do that after you've done this. So after you do this, the port is going to be occupied by just this one. And for me, I only have one port working with Arduino. You can have 2 ports and it's actually a little bit easier, but once this is run, you have to close it before you can run something on the Arduino. The next step is we're going to go into the package that I made myself. So catkin workspace. All right, and then the same thing, we want to source the correct file or the setup file. And that way it can detect know what I'm talking about pretty much. Let's see. And there we go. So right now I'm going to run the ROS run Bluetooth interface. That's the one that I made, the Bluetooth interface node.py. I'm going to hit enter, and now it's running. The last thing that you don't have to do, but is useful, especially for in the testing phase when I was doing that, is ROS comes with something really nifty called a ROS topic. And then you can do ROS topic echo slash, what did I call it? I'll look that up really quick. So believe it is target distance, and it'll let me know if it doesn't see anything. So yep, it did see something. And I was also getting my phone just to show you guys what it looks like. So I'm running a numerical system with this, the forward and back button that you saw. So I'm gonna just, well, first I need to connect. I don't know if the phone is close enough for it to connect actually. Oh, okay, good. So we're gonna go to manual control. So that's just one of the sub menus that I made. And then I'm gonna click forward. You'll notice it says not a number, and I'm gonna go over the code in just a little bit. But it recognizes if it's a number or not, and it publishes it if it is a number. So it says received B 0.2. B is just the byte, or B I think stands for byte. And you can see over here, echo target distance. This is a completely different terminal, yet it got the same number. That's because the topic is keeping track of what is, or the topic is what ROS keeps its programs all together. So the whole numbering system that I'm using was what I was using to make it go back and forth. Like I said, it would have been a little bit smoother. And the last video I showed that it can smoothly stop at one point, but it's just the wheel coming off. But I'll just show you a few more times what it looks like. So let's do forward. You'll notice the numbers get a little weird. There's one that says that gets very close to 0. So it's not 5.55, it's 5.55 times 10 to the negative 17th. I have no idea why they couldn't just say 0, but it's pretty darn close to 0. So it doesn't mess up the robot at all, obviously. And then we can go into the negatives, meaning we can go backwards, and that's how I did go backwards. So I'm just going to go over the code. So I mean, I'll close this one out first. So if you wanted to just press Control C, and this closes the ROS serial, and then you can upload to the Arduino. But let's go into the code a little bit. So I'll first go into the Arduino code. I just updated that a little bit, so thought it might be nice to show you guys what I updated. And then I'm also going to go over the Python code, or the code that I made with ROS SDK. All right, so this is the temp file. Let's see if I can find the actual one. And there we go. Let's get rid of that one. So if you'll notice, the Arduino code looks a little bit different because I did need to add these two at first. So ROS.h, it comes with ROS code. I believe there's also ways to download the libraries on Arduino. But obviously without ROS, it's kind of useless anyway. So might as well download that and test it first. The node handler is what listens to those nodes that I was talking about, where it's printing out negative 0.8. And from that node, we're going to take a few different things. So the void distant callback, this is going to take the previous distance just to know which direction it wants to go as the last target distance. So obviously the first time it's going to be 0. So no matter which direction it is, that's correct. And then so forth, so on and so forth. The subscriber, this is the probably one of the most important parts of the code, because this is what's listening for or subscribing to that node, is what how they say it in ROS. So you subscribe to the distance sub, and that for the setup, and then we loop by doing nh.spin once. I'm not really sure why we use this, but in every code that I've seen, if you need to loop in Arduino, you need to use this at least once, nh.spin once. The rest is should seem pretty similar, just from my last video. The difference is the target distance minus position 1. And if there is a difference, or the absolute value of that, then, or it's less than 0.6, then it's going to stop the motors. Otherwise, what it's going to do is compute with the PID loop, and then the target distance and the previous distance are going to determine which direction it's spinning. So let's go into a little bit into the ROS code that I made. So here it is. The Catkin, what I called it is just Catkin workspace. Catkin is a command, so it's just a popular name for any start. You'll notice three different folders. We're going to go into the source folder and then go into Bluetooth interface, which is what I made. And then we're going to go into Bluetooth interface node.py. And then, so what you're seeing well, I guess it shouldn't, but if you've noticed in any of my previous videos, or if you looked at any of my other GitHub code, for Python, receiving commands in Python, this is pretty similar, but there are quite a few differences as well. So this is the distance publisher. I imported ROS.py. Again, that's something that I think you need to do with pip. It's not just done with ROS, like it's not just installed with ROS. You need ROS.py.init node, and then I specified Bluetooth interface node. The distance publisher, this is what's going to publish to the rest of or what you saw in the terminal. So it's going to publish that throughout the entire computer. And what ROS uses is something called a server. So it kind of makes your computer into a server. So this publishes it to the server, like, hey, this target distance is what we're looking for. What it's going to do is it's going to receive the data in bits through the Bluetooth, and then it's going to try, so I'm coming back to this, but it's going to try to get the target distance equal to float of the received data, which is highlights it, I guess, but it's the Python code that it received from the bits, and then it distance pub.publish, which is the command, the target distance, which is what we're trying for. So notice I did not, I tried to use a try and accept function, or try and accept, or try and catch, if you will, to make sure that this actually is a float. And when I first started, what would happen is this entire program would crash because obviously some of the things that I receive are not going to be a float. They're going to be a string sometimes or something else. So that's pretty important. I wish I could do an entire video of ROS SDK and how to install it and how to work with it. There's a lot of videos that show you how to do that, and I would definitely recommend just looking in Google or any search browser you'd like to try to look at tutorials on how to download that. But I would like to go into how to make the just the basics of how to make this. So in your terminal, what you're going to want to do is choose make directory. And then obviously mine was catkin workspace. And then with that, you're going to, well, and it depends on the version too. So for Noetic, you're going to make a source file or a devil file, I guess, is what I made. You go into the devil file, and then you what you'll do is you'll type a command called catkin make. It's here, let's see. I can open up another. Yep. Kind of looks like this. And I'm not going to enter because I think that might actually try to upload again. But catkin make basically makes all of your source files, .lock, setup.bash, all of that kind of stuff is made with the catkin, and then that space in between like that and make. So that's the command that just makes it. It's pretty simple to just start making your own. It's a little bit more complicated to work with others or with GitHub packages that have already been made. But the main thing that you need to know with ROS Noetic, which is the distribution I'm using, is that it does need Ubuntu 20.04. It's I have tried it on 22.04, the newest version of Ubuntu, and I had a very hard time with that. So it's a lot easier to just to have the exact software that they recommend. There is ways around it, but it took me quite a few hours to figure out that it was not worth it. So I would suggest just working with the recommended software that they want you to use. But other than that, that is how my software works. Thanks for watching.